it'll say stop broadcast for when we're done. So when you're done, you just stop the broadcast and you go over here to this Creator Studio again. But instead of live streaming, you're going to go to Video Manager. Here's the, so 3, 4, 5, 6, 7, and 8. If I was to upload 8, click on the video that you want to upload, and the URL is right here on the right side. That's the one you upload to the group collaboration. That's the one that people will be able to, the TA and the professor will want to see. If you use the one here, then it's going to bring them to this same Hangout, but nobody's going to be on it. Does that make sense?
Yeah.
So they won't be able to see that we met.
Okay.
Cool. Well, are we ready to maybe get started?
Yeah, it's been a hard day.
Me too.
I did not like the exam. Oh,
well. I'm sorry. Okay, should we go ahead and someone want to say a prayer?
I'll say it. Dear Heavenly Father, we're thankful for this day, and we're thankful that we're able to meet as a group. We ask that we'll be able to retain what we learn, and that we'll be able to apply it and remember as we go through this quiz. We say this in the name of Jesus Christ. Amen.
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 Well, only 21 questions. I'm not gonna lie, I didn't get to the last part of lesson 9, the hypothesis testing. So might need some help on this one.
I'm gonna need a lot of help.
All right, Ross, it's up to you, I guess.
All right.
Okay, I'll take question number 3. Which hypothesis involves equality? The null hypothesis?
Yeah, that's what I had.
Okay.
Because the alternate is not equal to or greater or less than.
Thomas, someone's at the door. What's the true hypothesis? That's what they...
I thought the alternate was assumed to be true.
No, the null hypothesis is assumed to be true. The alternative is like the one that's not likely to happen. Are you going?
Oh, yeah, the word null. Okay.
Be good.
So we're at question 4?
Mm-hmm.
Yeah.
Okay, remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that's actually observed. When computing the p-value, which hypothesis do you assume to be true? Is that the null too?
Yeah.
Because the alternate.
That's what I thought.
That's what I put too.
Okay.
All right. Suppose the null hypothesis is that equation. Use the information entered in the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test? And that would be the alternative hypothesis, the mean is not equal to 10.
So that's the HA dot standard, that the line through the equal.
Yeah.
Okay, that's the one. Just want to make sure I'm clicking on the right one this time because I haven't passed.
Which of the following represents the alternative hypothesis for a left-tailed test? And I put the null hypothesis where the pop is less than 10.
Yeah, that's what I had.
So the second one.
That would be the first one.
The one
Yeah, and mine is the first one.
Okay, so the arrow, the bigger part of the arrow to the 10.
Yeah.
Yeah.
All right. Sorry, my brain. That was a hard thing. Okay. Which of the following represents the alternative hypothesis for a right-tailed test? Sorry. I don't know.
That's okay. With these ones, it helps me to write it out. Catherine, are you familiar with the greater than, equal to, or less than symbols?
The arrow? Yeah.
Yeah.
Sorry.
So if you want to like draw a timeline and just put a line with 10 in the middle, you can think of it as right-tailed means that the U is going to be on the right side of the 10. Or left-tailed means that the U is going to be on the left side of the 10. That might help a little bit.
Okay, so it's the opposite of the one you just did. So it'd be the little point is going towards the 10.
Yeah.
Okay.
Yeah.
You've got this, Catherine.
Thanks.
It is tough.
Yeah.
That it is.
Remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, which relationship would result in failing to reject the null hypothesis. I got p-value is greater than the level of significance.
Can you explain that one? So we're trying to figure out which relationship would mean that null hypothesis is wrong. So we would be using the alternative hypothesis, right?
So
So comparing the p-value, the p-value is the probability, right?
yeah.
Or the probability that we get in the study.
Yeah. Where was
So we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Is it greater than, or why wouldn't it be less than?
I saw, trying to find where that was.
Is it in the reading? And I'm just fine.
Level of significance. If the P is low, reject the null.
And where did that go?
We need a way to determine if there is enough evidence to reject the null hypothesis.
Oh, so it says in 4.4, it says we will use the same decision rule for all hypothesis tests. Less than alpha, we reject the null hypothesis. Conversely, if p-value is greater than alpha, we fail to reject the null hypothesis.
So if it's greater than alpha, we don't reject the null hypothesis. We keep the null hypothesis, right?
So yeah, we fail to reject it.
We fail to reject the null hypothesis. So, but what is the alpha? Like, I don't understand what the alpha is. Have they really explained more about it?
So the level of significance, I think it said more about that lower in the reading too.
So the alpha value is the probability of committing a type 1 error, which is rejecting the null hypothesis when the null hypothesis is true. So if it's if alpha is great, then that means it's more significant. Oh, the probability of committing a type 1 error.
At the bottom in the summary, it says the level of significance, which is alpha, is the standard of determining whether or not the null hypothesis should be rejected. Usual values for it are 0.05, 0.10, and 0.01. If p-value is less than alpha, we reject the null. If it is not less than alpha, we fail to reject the null.
Okay. I'm gonna have to go back and do this one again.
So this is the p-value is greater than the alternative? Is that what you said?
The p-value is greater than the level of significance.
Yeah.
Which is the little a? Yes?
Yeah,
It's the alpha.
Yeah. Which is the second one that I have on my paper, on my list.
I think it's the first one.
Yeah, so the p-value should have the two points towards it.
Okay, so I'm still getting confused. Okay. I'm going to be a lot of reading on this one too. Hope I can get it.
Okay, I'll go ahead. Which relationship would result in rejecting the null hypothesis, which means the p-value would be less than the alpha, so the second one.
Yeah.
Okay. Oh, great. Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use the information for the next two questions. Which of the following would be the appropriate alternative hypothesis? Okay, the average claim amount is equal to $1,500. The average claim amount is not equal to $1,500. The average claim amount is greater than $1,500. The average claim is less than $1,500. So they think it's higher. So would it be greater than $1,500?
Yeah.
And I think we were talking earlier about the right and the left-hand tailed, so this one would be right-tailed.
Because it's the greater. Okay.
Yeah, because it's on the right side of 1,500.
Okay. Thank you.
Which of the following would be the appropriate null hypothesis? And since null hypothesis is dealing with equality, then it would be average claim amount is equal to 1,500.
That's the original hypothesis that they've stated, right?
The null hypothesis, yeah.
Okay. Just, they don't have to throw in the word null, meaning not meaning void, but they have to make it confusing here.
They do like to make it confusing.
If they just use regular words instead,
Yeah,
that'd be nice. Okay.
that would be really nice.
Yeah.
The insurance company randomly selects n equals 40 claims and calculates a sample mean of 1,650. Use this for the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? It is a good assumption since the sample size is large. Is what I would put.
Because it's over 30, right?
Yeah.
Yeah, that's what I put.
Okay. What, I don't know how to say that word, theorem or law justifies your answer to the previous question? I didn't read what the law of total probability is, so I don't even know what that is. It's the central limit, isn't it? Or is it the law? Okay.
Yeah, with the distribution.
That does the 30, up to the 30.
Mm-hmm.
Okay.
Which of the following is the test statistic as defined in this lesson? And from what I found, it was Z.
Yeah, same.
So that's not the Z-score. That's a different Z now, right?
Yeah.
Great. No wonder people don't like this as much as they would like to if they could explain things better.
The historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store's manager suspects that the average has decreased. She sets a hypothesis test with the hypothesis that the null hypothesis is the mean is 150 and the alternative hypothesis is that the mean is less than 150. She will use a level of significance of alpha equal to 0.05. That takes a simple random sample of 36 receipts from her store and commutes that the mean is 144. what is the z-score associated? And the z-score be 6 divided by this 40 divided by the square root of 36, which is 6, which would be 0.9.
You like show me your paper when you're through?
Yeah, I can show you my calculator.
Yeah. I mean, of how you wrote it out, because there's like all these different numbers again.
Oh, it would actually be negative, not positive.
-9?
Negative 0.9. Hold on, give me 1 second. I'll write this back out. Divided by 6. Okay.
Okay, so 144, 150, and then divide again, and then divide again, and then you put the two together and you got the answer. Okay? Okay. Thank you. Are you still there?
So the z-score, what did you get for that?
She said she got a -9, -0.9. And it reads.
Did you get that too, Catherine?
Yeah, I'm redoing mine right now. We just work it. Minus -6. 4 divided by 36 equals 0.6. So 6 divided by 0. Yeah, I got 8.995 according to how I just saw it. Is that what you got?
I got -0.900.
How did you do it?
So I did 144 minus 150
Yeah.
divided by 40 divided by the square root of 36.
Oh, okay. So she did 4 instead of 40. Okay, let me redo that because it should have been 40 because I saw on her calculator it was a 4. So let me redo that. See what I get up there. Clear out. -6 divided by 40 square root of 36. 6.667. Okay, so -6 divided by 6.667. I still kind of got -0.8999. So it'd be -0.9 for me. Let me redo it.
What I missed? Sorry.
I was just redoing the problem?
15 or 16? Or 17?
15. What did you
Okay.
get for that again?
I got negative 0.9.
Yeah, that's what I got.
Okay.
Okay.
Are you still getting that negative 0.899, Catherine?
I did, but wouldn't I round that up to 0.9, negative 0.9?
Yeah.
Because if I got 0.899, would it be? So yeah, because I did the 144 minus 150, did that in the parentheses, got negative 6. And then I did 40 divided by the square root of 36 in the parentheses, and I got 6.666 on, and so I did it 6.667. And then I divided negative 6 divided by 6.667, and I got 8.999. So yeah, negative. So it turns to 9. Okay. All right. What is the p-value associated with the z-score from the previous question? So that is the probability value, right? And is that, I need to use the applet, right?
Yeah, but I can't find the link for the applet. It's not in the lesson and it's not in the quiz. Does anyone
I
have
think
it pulled up?
it should be at the top of the quiz, right above question 3.
Aha! Right above question 3. Okay.
Okay, I haven't done that either. Okay. I didn't see it either. Okay, let me go back and get back down here to question 11, 14, 15. So I put negative 9 in the normal app, is that right? Or is that different?
Negative 0.9.
Yeah, negative 0.9. That's asking for the probability.
I think so.
And which side am I going on, though? The greater
To the left.
to the left? Because it's less 0.184.
Yeah, that's what I got.
0.184.
Yeah.
That's what I got.
So can I ask how you knew that it was shaded on that side? So for my clarification.
Yeah, because from those 36 receipts that she took,
Uh-huh.
it was 144, whereas the normal mean was 150.
Okay.
So that's what made it
Left.
less than the normal mean, so it would be on the left side of that.
Okay. Thank you. I appreciate you explaining that.
Yep. What inference would you make about the null hypothesis for this problem? So the p-value. It has to do with if the p-value is greater than the z-score.
When you reject it?
I thought if the p-value is greater than the alpha, which is 0.05, you fail to reject the null. In section 4.4, it says if the p is low, reject the null. But in this case, the p-value is higher than the alpha, so we would
Fail to reject?
fail to reject the null. I think, at least, makes sense to me, I guess.
So you would fail to reject the null hypothesis on that, right?
Yeah.
Yeah, that was in the second paragraph on that 4.4 when you're reading it.
Yeah, it's at like the bottom of that section.
Always reject. Okay. Okay. I'll go with that. Okay, number 18. What is your conclusion for this problem? That it wasn't any fun. That's what my conclusion. Okay. We have incident.
If only we could type her in.
You can say this one's no fun. None of it's no fun. I would say I think it's insufficient evidence. Do you agree with that part?
Mm-hmm.
And I would say that the true population is they say the same thing. They both say no. One's sufficient evidence. Okay, I get it. It's insufficient evidence that it's less than 150.
That's what I put.
Because they were, as we discussed earlier, it was less than 150. It was 100 and whatever.
Yeah.
Okay.
All right. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? So that'd be type 1.
When we reject.
That's what I put.
When we reject. Okay, type 1. That's on the top. Okay, I see it.
So type 1 error is when the null hypothesis is true, but they thought it was rejected. Type 2 is when the alternative is not true, but that was the one that was accepted.
Is that when you're looking in that box that's here? No.
Yeah, so type 2 is the upper right-hand corner.
Okay.
Type 1 is the bottom left-hand. A researcher decided that instead of using a level of significance of 0.05, he will use 0.01, which is much smaller, which means the chances of the probability being larger go up that means that we keep the hypothesis, which means we have a greater error of keeping the null hypothesis even though it's not true, which would be a type 2 error, which means the probability of a type 2 error will increase.
I think so.
Because the p-value will more likely go up. I will most likely be higher than if it was 0.05. And
Yeah.
when the p-value is greater than alpha, that means you keep the null hypothesis, and that means type 2 errors will increase.
I'll go with that.
Right. Okay.
All right. Oh, okay. If the, let's see, whatever, the little a 0.05 computes the probability of committing a type 1 error, round to 2 decimals.
What does that even mean?
I don't know. That's
Here's the probability.
probably the we supposed to get the same numbers where? I am lost. I'm gonna have to read and see if I can figure it out, or am I using the probability applet for sure?
So go to 4.5 in the reading.
Okay.
It says the most common value for alpha is alpha equals 0.05. This is equal to 1 over 20. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance.
So that would be 0.05. Right?
No, it'd be 0.2 to 20%. Wait. Or would it be
Because that's 1 out of 20.
out of 20?
And if it was 20%, that would be
You're right.
4 out of 20.
0.05.
Yeah. Yeah, 0.05. It's like a question. Makes you think there's going to be math.
Yeah. So almost every question makes me think. Like, oh, great. Okay.
Let's see how we did here. So far, so good. So far, so good. So far, so... number 11. That's the only one, though.
Number 11.
Yeah, I got that one pulled up.
Yeah. Just looking for.
I'm going to pull it back up real fast.
No hypothesis. That's that. You okay?
You know, it's Tank, my baby. He's just funny.
What's his name?
His name's Tiankum, but we call him Tank.
Oh,
And
that's
he's over the past couple months, he's figured out he can like make lots of different noises. It's
And
just funny.
how old is he?
He just turned 1 a little bit ago.
Oh, well, how fun is that?
Yeah, it's really fun. It's a lot of fun.
Yeah, babies are
Okay,
fun.
let's see. Did we figure out what we did wrong on number 11?
No.
Not yet.
Alternative, the average claim. That was an easy one.
What did you have before?
I put the average claim amount is greater than 1,500. No, I'm sorry. Oh, I might have put the answer in wrong. I think I put the answer in wrong. You guys put the average claim amount is equal to 1,500, yeah?
Hold on. Equal to 1,500, yeah. Average claim amount is equal to 1,500.
On the wrong one because I put the average claim amount is not equal to 1,500. So I think we're good. That was just user error over here.
Well, I'll click in, save it.
Yeah, that was my bad.
I just submitted it. I'll see what it does. Besides not doing my homework.
I gotta get going. I have another group meeting.
Everything's good. Everything's right.
Okay, awesome. Thanks, Ross, for your help.
Thank you.
I'll see you guys next week.
See ya.
Yep. Hopefully I still work through this. Oh,
Yep.
this is a hard class in ways for me. Anyway.
Difficult one. All right. I think that's it.
Alrighty. Thank you.
Okay, we'll see you, Catherine. Have a great night.
You too.